Don't forget to subscribe and ring that bell.
I'm still excited. I am still excited. It has only been 2 to 3 days since we took the exam and we have the free response questions in hand. I'm pumped, kids. 2024, free response question 2. All right. We get a graphing calculator and enough said. Let's slay this problem. Let's cook, kids. Let's cook. Number 2 tells us a particle moves along the x-axis so that its velocity at any time t is greater than or equal to 0. It's given by v of t, which is the ln, or natural log, of t squared minus 4t plus 5 minus 0.2t. Now, 2a states there is 1 time t. We will call it tr. Okay? In the interval between 0 and 2, where the particle is at rest. And I love how they got to put in parentheses, it's not moving. It's at rest, it's not moving, kids. Okay? Find tr. Now it says, for some time t, between 0 and tr, is the particle moving to the right or to the left? Give a reason for your answer. Let's do one thing at a time, and let's start with a nice, an orange. Okay, first of all, there's 1 time t. They're going to call it tr. It's between 0 and 2, where the particle is at rest. Find tr. Find the time. They call this time. The sub r means time at rest. Okay, here's velocity. If something's not moving, the velocity needs to equal 0. We have a calculator. So why not put this right in the calculator? And that's exactly what I'm going to do. Boom. My velocity is the ln of x squared minus 4x plus 5, close that parenthesis out, minus 0.2x. Now, I only want to look between 0 and 2. Okay, it's right there between 0 and 2. Okay, well, actually, do they give us another interval? Yeah, it's between 0 and 2. I want to make sure that was for the first part, not the second part. Okay, so I'm going to graph this. I'm going to change my window between 0 and 2. I'll leave the y's the same for now. Let's see what happens. There's 1 second. Oh, yeah, it crosses between 1 and 2. I need to find this point of intersection right here. Okay, so I'm going to use second trace the 0 function. And I am going to make sure my cursor is to the left of that orange dot. And it is. I'll hit enter. And I got to go to the right of that. And I want to be obvious with it. I'm now far enough to the right. And when I hit enter one more time on the bottom left, it's going to tell me what that 0 is. It is 1.426. We will round this 5 up to a 6. 1.426. So, because let's call this T of R equals 1.426. It does not say seconds or minutes or whatever, so we're just going to leave it like that. But for part A, I like to 0, 1, 2, and we have something that goes something like that. And right here, time is approximately 1.426. Let's make sure I got that right. I did. There it is. All right, so that's for the first part of A. Now we have a second part. Okay, we have a second part. And this graph is going to help us answer that second part. So first of all, here's our first answer. All right. The second part says, now, for some value time in between 0 and T of R. No, this is T of R. So in between 0 and right here. Okay, in this interval, and we're going to highlight this because I like to use the highlighters. Okay, and here on my graph, I don't care about anything else that's not between 0 and 1.426, which we call TR. Is the particle moving to the right or to the left, and give you a reason. Let's not forget, this graph y is the velocity. Okay, so anytime my graph is above the x-axis, my y values are positive, which means my velocity is positive. If I'm below the x-axis, my y values are negative, so my velocity is negative. But I only care about this chunk. It is above the x-axis, which means my y values are positive, which means my velocity is positive. How come? Because this is the graph of velocity. My y value is the velocity. All right. So give a reason. Let's say, first of all, it is moving right. Moving right. Okay, give a reason. Since v of t is greater than 0 between 0, and you can say t of r, or you could do your 1.426. There you go. Because in the interval they gave us, velocity is positive. So the particle's moving right. We are done with 2a. And there are two answers, boxed in black. 2b, find the acceleration. Okay, find the acceleration, red. Find the acceleration of the particle at time 1.5. Show the setup for your calculations. Oh my God. Is the speed of the particle increasing or decreasing at time t equals 1.5? Explain your reasoning. I mean, guys, let's do the first part. Acceleration at 1.5 is the same thing that is the velocity. Derivative of 1.5. The derivative of velocity is acceleration. They give you velocity here. We have a calculator. That's approximately. Boom, boom. Do I have that in y equals? I do. In y1, I don't normally do this. Someone mentioned this in the comments. And I don't normally do this. But it is really, it'll save you time for retyping things. y1 is now assigned my function velocity. Okay, so what I'm going to do is I'm going to go to math 8 because I need the derivative of velocity to get acceleration. In here, if I go to vars, you see this button right here? Blah, 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 vars. It's below the little directional arrows thing there. And I go to y vars, and I hit function y1. Whatever is in y1, in this case, the velocity, that's what it's going to take the derivative of. And we want this at 1.5. Do we not? We do. And we should get negative. I hope you know, if I round this 3 places, that will turn to a 0, 0, 0, boop, -1. So it's -1. So I'm going to say a of 1.5 is -1. Now, I need to know if the speed of this particle is increasing or decreasing. That's our answer for the first part. In order to find if something's increasing or decreasing in speed, I need to look at acceleration and velocity. If the speed is increasing, these signs need to be the same. If the speed is decreasing, these signs should be different. Okay? Right now, I know my acceleration is negative. So I'm either here or here. I don't care about this option or this option. So either my velocity is negative, the signs are the same, and I would be increasing the speed, or my velocity is positive, the signs are different, and my speed would be decreasing. I always say this is a lot like multiplication, right? When my signs are the same, don't I end up with a positive product? And when the signs are different, don't I end up with a negative product? I do. Now, I don't want you to multiply the numbers together and tell me that's the actual value. You just tell me whether it's increasing or decreasing. All right, so I can look back. Okay, we're looking at 1.5 seconds. In this graph right here, let me get all this jazz moved aside right here. If this right here is 1.4 seconds, 1.42. 1.5 is going to be right here. Looks like to me the y-coordinate of velocity will be there, and it will be negative because it's below the x-axis. So I don't know if we can refer to problem A, or if you really want, you could just figure out what the velocity is at 1.5. Okay, and since we already have this on the graph, let's go to graph. Let's go to our table. My table only goes up by ones. So I'm going to go to second window, which is a table set. Start at 0, but instead of going up by ones, that means a change in the table. I want it to go up by 0.5. Now look, you'll see when the velocity is 1.5, or when the time is 1.5, the velocity is negative 0.77, we'll call that. So we definitely have a negative velocity. It's not this one. My speed is increasing, all right? So they want us to answer whether it's increasing or decreasing, then explain. So I'm going to say speed is increasing at time equals 1.5 since A of 1.5 is greater than 0 and, oh, excuse me, less than 0, and V of 1.5 is also less than 0. Done and done. Man, for a calculator, but this is a great calculator problem. I love it. 2C. The position of the particle at time t is x of t. And the position at time t equals 1, x of 1, is negative 3. Okay? That means when the time is 1, the position is negative 3. All right? Find the particle at time t equals 4. Show the setup for your calculations. My God, if you weren't watching problem 1, for 1, was it B? For 1C, okay? I'm going to go back to 1C for a second, okay? Because I said you would see this at least once on your exam. You're seeing it twice in 2 free response questions. I said this was 1C. It's 1D, 1C, where I have to take an integral of a derivative, go back to the original equation with the bounds, upper bound minus lower bound. They'll give you one of these bounds, and you got to solve for the other one. You always see that. And I said that in the review video. And any time you take this exam, you're going to see this. And it happened not once in the free response question 1, but it happened a second time in free response question 2. 2C. Bam. And let me explain. All right. They give us, okay, they give us x of 1 is negative 3. They want us to find, okay, x of 4 at time 4. That's what we're trying to find, all right? The velocity is the derivative of position, is it not? The derivative of position is velocity. So if I integrate x prime of t, which is velocity, dt, that will result in our position, which is x of t. And if I put bounds here, let's say from 1 to 4, that means I go from x1, or excuse me, the upper bound minus the lower bound. That's what we're doing. Man, this happened twice in the first 2 free response questions, all right? They give us x of 1. So I'm subtracting a negative 3. They give us this. This is what we're finding out, okay? And I just got to put this in the calculator. All right, well, let's do that. Second quit. Let's get our equation. There it is, up there in the top right. Clear this out, go math 9 from 1 to 4, I am integrating the natural log of x squared minus 4x plus 5, close that parenthesis out, then subtract 0.2x, close that parenthesis out. Wait. Ooh, I put 2 parentheses. This is weird. Let's delete this one. Okay, that's the ln of that. Minus, then I don't need this one. That got, well, we got crazy for a second there, kids. It got real crazy. All right, that dx. Let me make sure one more time. Yeah, the ln of it. Yeah, so what I like to do is I got this for this one, and then I got this one for this one. Okay, they match. We're good to go. You don't want to get one of those errors, and you're like, I typed it in right. Okay, so if I hit enter, I get negative, or excuse me, I get 1 point, what do I get? 1.97. Yeah, it's called 1.97. Well, 3 decimal places. Okay, so this is, well, it's 0.197. Okay, so let's keep in mind that when I subtract a negative, it's like adding, correct? So how do I get rid, if I'm solving for this here, I just got to subtract 3 from both sides. So my x of 4 is going to be approximately, and let's go back to the calculator, and let's just take our answer and subtract 3. Negative 2.803. We'll round that up. Negative 2.803. There we go. Man, I tell you, I am loving this test so far. Not too shabby. 2D. Find the total distance traveled by the particle over the interval from 1 to 4. Show the setup for your calculations. Guys, man, oh, Lord, I know I have said this, and I think this even popped up. It may have popped up in the review video that whenever I integrate something, okay, let's call it, I don't know, f of x, dx. This gives you the displacement. That means how far, let's say, a particle is from where it started. But if I do the same thing, but I put absolute value bars there, now it's not displacement, it's the total distance traveled. Okay, total distance traveled. Look what they're asking us for, kids. Wow. So if I want the total distance, okay, I'm going to integrate velocity, but I'm going to put it in absolute value bars. That is it. And they give us our bounds from 1 to 4. So let's integrate from 1 to 4. And the beautiful part is I only got to do v of t here, dt. I mean, you don't need this in black. You don't need this written here. Okay, I just have it there for review purposes. Okay, and let's figure out what that is. Yeah, okay. Let's go here. What do I have in y1? Oh, I do have it in y1. I do have it. So I could have integrated y1, but let's do it again. Okay, so I go math 9 from 1 to 4. Okay, I want to integrate. All right, I want to integrate my y1. I want to integrate this equation. That's my velocity for this problem, and it is assigned to y1. So right here, I need to put the absolute value bars. Okay, so if I hit math, I move over to number, choice 1. Boom. And I'm going to put vars, y variables, enter, enter. I'm going to integrate the absolute value of y1 with respect to dx, and I get some sort of number that doesn't seem right, but it is right. Okay, it's still thinking. It's still thinking. There it is, 0.958. Doesn't ask you for any label, doesn't ask you for anything fancy. It asks you for the setup and the equation, well, excuse me, the setup and the answer. And part one, free response question one, free response question two, they're done. They weren't that bad at all. I'll see you for free response question three soon.
Don't forget to subscribe and ring that bell.